Hello everyone, in this video I want us to look at solving radical equations. Again, what makes it radical is just we're going to see that square root symbol in it, and the equation again just means it's equal. So just like with solving linear equations, our goal here is we want to get that x by itself. Okay, so solving a radical equation, your first goal is you want to get that square root term isolated on one side of the equals by itself. And that, in this case, we already have that. So in order to get rid of that, we're going to square each side. Now remember, a square root and a square cancel. So that's going to leave us with 3x minus 2. And then x squared is just x squared. All right, now we want to, what we see is that we have a quadratic equation now. And so we want to solve this quadratic equation. So remember, in order to do that, we first need to get it equal to 0. So we need to bring this 3x over and this negative 2 over. So to do that, we're going to do the opposite operations. So minus 3x and plus 2. That's going to give us 0 on the left equals x squared minus 3x plus 2. All right, now we want to solve this quadratic equation. Let's do this by factoring. So this factors into two factors that multiply to give me 2, add to give me negative 3. That's negative 1 and a negative 2. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. All right, now we take each one using that zero factor property. We take each factor and we set it equal to 0. All right, solving each one of these gives me x equals 1 and x equals 2. Now, normally when solving linear equations, we'd be done. We could check our answer if we wanted to, but we didn't have to, we'd be done. When it comes to radical equations, you have to check your answers. All right, sometimes when you square sides, you create what's called extraneous solutions, kind of fake solutions. And so we just have to check them to make sure that they work out. So going back to the original equation, which was square root of 3x minus 2 equals x, and we're going to plug in each one of these values. So let's do the 1 first. So square root of 3 times 1 minus 2 equals 1. Well, 3 times 1 is 3, minus 2 is 1, so we get the square root of 1 equals 1. Square root of 1 is 1, and so it checks out. And so that tells me that x equals 1 is indeed a solution. All right, now we're going to check 2. So if we plug in 2 for x, we get 3 times 2 minus 2, and we're saying that that's going to be equal to 2. So 3 times 2 is 6, minus 2 is 4, so we get the square root of 4 is equal to 2. Well, the square root of 4 is 2, so we get 2 equals 2, and again, that is true. So that tells me that x equals 2 is also a solution. So in this case, both x values worked out, so both are answers. All right, let's look at one more. Let's say we want to solve square root of 4x minus 12 plus 3 equals x. Now, keep in mind, before we start squaring each side, we need to get that square root term by itself. So I'm going to go ahead and subtract the 3 over. That's going to give me square root of 4x minus 12 is equal to x minus 3. Now that we have the square root term by itself, now I'm ready to square each side. Well, again, square root and a square cancel leaves me with 4x minus 12. On the right side, we're actually going to have to FOIL this out. Remember, that's x minus 3 times x minus 3, which is going to require us to FOIL that out. So that is 4x minus 12 equals, if I FOIL that out, I get, remember, first outer, inner last. So that's x squared minus 6x plus 9. Okay, so when we FOIL that out, that's what we get. Well, now it looks very similar to the previous problem where we have a quadratic equation and we're going to solve it. So we need to get it equal to 0. So I'm going to subtract 4x and add 12. I'm going to subtract 4x and add 12. Leaves me with 0 equals x squared minus 10x plus 21. So now we're looking for two factors for this trinomial. So we know we got x and x. And now we need two numbers that multiply to give me positive 21, add to give me negative 10. Well, that would be negative 7 and negative 3. Now, zero factor property, set each one equal to 0. And solve. So we get x equals 7 and x equals 3. But again, we're not done. We have to plug these in and check them. Okay, so we're going to check them over here. So if I plug in 7, that is square root of 4 times 7 minus 12 plus 3, and we're saying that that should equal 7. Well, 4 times 7 is 28. 28 minus 12, that leaves me with 16 plus 3 equals 7. Square root of 16 is 4 plus 3 equals 7, and that is 7 equals 7. So checks out. So that tells me that x equals 7 is one of my solutions. Now we're going to check x equals 3. So we plug in 3 everywhere we see x. So we have 4 times 3 minus 12 plus 3 equals 3. Well, 4 times 3 is 12. So we get 12 minus 12 plus 3 equals 3. Well, 12 minus 12 is 0. So we get square root of 0 plus 3 equals 3. Square root of 0 is 0. So 3 equals 3. And again, it checks out. Okay? And so what does that tell us? Well, that tells us that x equals 3 is also a solution. Okay? So again, when we're doing these radical equations, your first step is to get the square root term, the radical term, isolated on one side by itself, and then we square each side to clear the radical, and then we solve for x. Now, we do have to take these, plug them back in to see if they work. If they work and they check out, then it is a solution. If they do not, then that is not a solution. It's what we call an extraneous solution, but it's just a fake solution that we created by squaring each side, and so it does not work.